Here we have a question that asks me to plot a graph. So you can see I've got my graph paper out and ready to go, and I've also chosen a suitable scale. I'm given some information and then make some estimations. So what I'm going to do is I'm going to plot in red. And if I do that, I know that in 1836 Melbourne's population was 177. That point is going to be about there. In 1854, which is somewhere around about here, it was 123,000. So that point's going to be there. 1880, 280,000. So somewhere around about there, and so on until I've got the entire graph sketched. And you can see now that I've got all my points plotted on the graph. Now the next thing I need to do, remember, this is actually a time series graph, so I should connect the points up, and this might be quite interesting. But it's going to look something like that. My line will look something like that. And for this bit, who knows where it's going to go? Of course, we don't know, because that actually is extrap. It's extrapolation here. Inside is interpolation. Outside of my last data point is extrapolation. Now I'm going to use my plot to work out what the population was in 1920 and 2020. So what I'm going to do is I'm going to get a pink line and I'm going to line it up. Actually, I don't need to do that. Line it up. This line here is 1920. And it looks from my picture as though the population in 1920, which should be there, is somewhere round about 1 million. So I'm going to write here 1 million people in Melbourne in 1920. Now in green, I'll have a look at 2020, and that would be here on my graph. So if I come all the way up here, it looks like it's somewhere round about 4.6 million. Remembering that the way you draw your graph will determine what your numbers are, and the examiner's looking for a reasonable attempt, and they will give you a range with which they would give you the mark.